Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 2 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino R4 Wi-Fi board. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, if you guys do not have your gear yet, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick your gear up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. First of all, I hope most of you guys did your homework last week. What was your homework assignment? We had the Arduino R4 board, and we showed that we could blink that onboard LED because that onboard LED was connected to the pin on the Arduino board, pin 13. So if we turn pin 13 on or high, put 5 volts on it, the onboard LED comes on. If we turned it off, the LED turned off. So it was really cool. We wrote our first program last week. But what your homework assignment was to see how quickly you could blink that LED and have your eyes still perceive it as blinking and not just look solid. Now, you were supposed to post that to YouTube, and then you were supposed to link back to my video, and then down in the description, you were to link over to your homework assignment. And I look at every single homework assignment that you post, and I try to make comments on it. Okay, so make sure you guys are getting your homework done. So last week we wrote our first program blinking the LED that was on the Arduino board. Well, what are we going to do today? We're going to build our first circuit, and we're going to build our circuit, and we're going to blink an external LED. We're still going to be using that pin 13, still turning pin 13 on and off. So the coding is not going to really change. But what are we going to do different? We're going to build our first circuit. Does that sound good? I hope it does. Okay, let me have a sip of coffee. Let me get out of your way. And then let me come over here. And let's see if I can kind of draw this thing up for you. So if we are going to build a circuit, the first thing that we're going to need to do is kind of have a schematic or a roadmap of what this circuit is going to look like and what's it going to do. Well, the first thing we're going to start at the Arduino, and that is going to be our voltage supply. And we draw a voltage supply as a little circle with a plus and a minus. It almost looks like a little battery, okay? But we're not using a battery as our voltage supply. We're using the Arduino board. What on the board? We're going to be using pin 13. We turn pin 13 on and off. That will be turning this voltage supply on and off. Now we're going to want to turn what on and off? An LED. Well, an LED we're going to put in the circuit here in our schematic, and this is the symbol for an LED. It's a triangle with a line like that, okay? Now, what you're going to see is that when you get your LED out of the kit, it has 2 legs. One leg is a little bit longer than the other one, and that's very important. That long leg, when we actually put this together, you'll have a long leg and you'll have a shorter leg. That long leg, I'll call it LL, always needs to point back to the positive on the voltage supply. Okay, so it has to go in this way. It can't go in the other way. If you put it in the other way, it doesn't damage anything, but it just won't light up. It only lights up if it goes in the right direction. Now, one of the things about the Arduino R4 board is it is able to generate 8 milliamps, 8 milliamps of current. Okay, and so it's very important that we don't draw more than 8 milliamps out of the Arduino pin, because if we do, you'll let the smoke out of the Arduino. Once the smoke comes out, the Arduino won't work. It has to have that smoke in there to work. If you let that smoke out, it's not going to work. You're going to have burned up your Arduino, and you don't want to do that. So we don't want to just take this and connect it back to the ground. We need to put a component in there to make sure that we don't draw too much current. We want to limit the current. We want to choke it down. So we need to resist. We need a what? We need a resistor. And so we are going to need a resistor in here like this. And so then the other end of the resistor will come back to the Arduino. So right here at the negative end, that is going to be the GND, the ground pin. Okay, the GND pin. What is the plus? That is pin 13. So the voltage supplied, the plus on this schematic goes to pin 13, and the minus on the Arduino goes to GND, or the ground. Now we're going to have the plus of pin 13. We're going to have that connect to what? The long leg of the LED. The short leg of the LED is going to go to a leg of the resistor, and then the other leg of the resistor will come back to ground. So it's like we're creating a pipe, and electrons will flow through that pipe, and the amount of electrons flowing through that pipe is the current. The current is represented by the letter I. Okay, I represents current, and that current we want to be no more than 8 milliamps. If we just plug this in without the resistor, the current would be more than 8 milliamps. We would either burn out the LED, or we would burn out the Arduino, or we would burn out both. So we need to put a current limiting resistor in here. But what value of resistor? We have to calculate that value. Well, how do we calculate it? We calculate it using Ohm's law. Okay, we calculate it using Ohm's law. And I'll go ahead and label this as R, our resistor. Well, what is Ohm's law? Ohm's law says that the voltage across a component is equal to the current through the component times its resistance. V is equal to IR, and that is Ohm's, Ohm was a person, Ohm's law. Okay, Ohm's law. Now, what do we know? We know that that pin 13 on the Arduino generates 5 volts. So we have that. So the V is going to be 5. All right. Now, what current do we want? We want 8 milliamps. But you don't plug 8 in here because you've got to plug it in amps. Well, what does milli mean? Milli means 1/1000th. Okay, so to change this to amps, we're going to say I is equal to 8, and the milli becomes divide by 1,000, like that. So the current is going to be I is equal to 8 divided by 1,000, and then we are in amps. So we have replaced the M where we had M. We've replaced the M with 1 divided by 1,000. Okay, and so here we are. The current that we want is 8 divided by 1,000 amps, and we can put that in our calculator. And even though I can do that in my head, I'll do it along with you. 8 divided by 1,000 is equal to what? 0.008. So this is 0.008. Now, what are we back here at Ohm's law? 5V is equal to I. What current do we want? 0.008 times the resistance. So what is the resistance? That's what we're trying to figure out. So what do we want? We want R by itself on one side of the equation. So how do we get R by itself? We divide both sides by 0.008. So 5 divided by 0.008 is equal to 0.008 divided by 0.008, which is just 1, and we're left with what? R. So R is going to be equal to 5 divided by 0.008. 5 divided by 0.008 0.0008 is equal to 625. Okay, so the resistance that we want is 625, and the unit is ohms, and it's that symbol. So the R that we want in this circuit is 625 ohms. So we've got 5 volts, we've got an LED, we've got a resistor, and so now we need to build this circuit. Okay, we need to build this circuit. So what we need to do is we need to get our components out of our kit. Well, what are we going to need first? We are going to need this voltage supply. Where do we get the voltage? We get it from pin 13 of the Arduino. And so as you get your kit here, let me back up so you can kind of see this. Okay, as you get your kit, you need to look down here and you need to find your Arduino. So you're going to need that. Okay, what else are you going to need? You're going to need an LED. Well, the LEDs are here. Mine are in the upper left, and they're these little things. Now, very important, we are going to use a red LED. Blue LED are only for special occasions, so you are not to use a blue LED. Only in this homework assignment, you have to use the red LED. So we're going to get that one out. We'll save the blue ones for something, some special occasion in the future. So I get the red LED out, and I seal this back up, and I put it back in there. So now I have the LED. Now what do I need? I need a resistor. Okay, these are the resistors. And there's many different resistors, but we'll just get them out and then we'll find the one that we want. So we've got the LED, we've got the resistor. Let me get my Arduino out. I'm kind of trying to lay this out like we're going to build it. And so here is the Arduino. And then here is pin 13. That is going to be the plus here. It's going to go over to the LED. The LED is going to go to the resistor. And I need a resistor of 625 ohms. Well, you can imagine that you want, you're not going to have exactly 625 ohms. So you want to find one that's close to that. So let's get these resistors out and let's look and see what we have here. Okay. We see that we have 10K. And we're going to learn that K stands for 1,000. So 10K would be 10,000 ohms. That's way too big. That's not very close to 625. So we're going to put that over there. We don't want that one. Oh, look, 1K would be 1,000. 1,000 is pretty close to 625. So we are going to keep that one here. This is 330 ohms. Well, that's kind of close to 625, so we'll keep that one. This 100R would be 100 ohms. 220 ohms. Well, the thing is 330 is closer to 625 than 220, so we're not going to try that one. 1M would be 1,000,000 ohms. 10R would be 10 ohms. That's much too small. 100K would be 100,000. That's much too large. 5K would be 5,000. That's much too large. 2K would be 2,000. That's much too large. So what we have is the two contenders are 1K. Our two contenders are 1K, which is 1,000, and 330 ohms. And so now we got to figure between those two, what would we want? Between those two, what would we want? And it's very important for us to approximate this correctly. Okay, it's very important for us to approximate this correctly. What are we trying to do? We're trying to limit the current so we don't burn out the Arduino. So if the resistor is a current limiting resistor, should we use one that's a little bit too big or use one that's a little bit too small? Since it is resisting current and resisting burning the Arduino out, we want to use the one that is too big, 1,000. Because if we use the 330 ohm, it might actually let the current be enough to burn this thing out. And so we are going to use one of these. All the rest of these are going to go back in the package and go back in the kit. Okay, so keeping our kit neat as we should. Now what I'm going to do is I'm going to pull one of these off. So you just kind of pull it off, and I'm going to try to put it back later. And so there, I pulled it off, Now these I'm going to put back in the sack. Okay, we are moving along very nicely here, very nicely. Okay. I think I can zoom in a little bit now so you can see more what we're working on. Okay, so now to build this circuit, what I'm going to need is I'm going to need a couple of wires. All right, so this, and remember the long leg has to go back. So I need to connect this over here to pin 13. Then I need to connect this to one leg of the resistor, and then the other leg of the resistor needs to come back to pin, the other leg of the resistor needs to come back to GND or ground. Okay, and then I'm going to kind of like complete my circuit, and then that old program that we used last week should work. Now I'm going to need a couple of other things. I'm going to need a couple of wires, and so get out of your kit. I'm going to get the black wire, okay, and that's in the lower level, and the red wire. All right, now the red wire typically stands for positive, so I'm going to take that red wire and I'm going to put it into pin 13, and you got to look really careful. You don't want to miss that, but that will plug in. Let me see if I can let you see that a little better. Yeah, you see that? I'm going to go right into pin 13 there, make sure it's all the way in, and then this other one is going to be our ground. Okay, so now I have pin 13 and I have my ground, and then this red wire, which is the pin 13, it needs to go to the long leg of the diode, and then the short leg of the diode needs to connect to either leg of the resistor. So on the diode, it has to go in, the diode has to go in the right direction. The resistor can go either direction. Okay, the resistor can go in like this or like this. Either one will work. Okay, so you see I've almost got my circuit hooked up here, but I got to get it all hooked up. Okay, I've got to get all those different pieces hooked up, and in order to do that you need to learn how to use a breadboard. And so inside your kit on that top level is a breadboard, and what you do is you build your circuit on this breadboard, and it allows you to make all your connections nice and easy and neat. But in order to do that, you have to understand how the breadboard works. Okay, so I'm going to give you a quick summary here of how the breadboard works. And so this is a schematic of the breadboard. Now what the key is to understand on this breadboard, along a column, do you see this red column here? All the holes, all the holes along a column are connected together. So if I wanted to connect the short leg of the LED to a leg of the resistor, I would need to plug the short leg of the LED in here, and then one leg of the resistor into the same column, because the holes in a column are connected. So if I plug something in here and I plug something in here, they're going to be connected. So holes in a column are connected together. Holes in a row are not connected together. So if I plug something in here and here, it is not going to be connected together. So isolation along the row, connections happen along the column. But there's a special case. Across the trench, look at your breadboard. Running down the center is a trench. They are not connected across the trench. So all of these in red here are connected. All of these in blue are connected, but these red holes are not connected to the blue holes. So if you plug something in here and plug something in here, they would not be connected. Okay, columns are connected together. Columns are connected together, but those columns are broken across the trench. And then along a row, you are not connected. There's 4 special rows. All the holes in the top row are connected together. And you can remember that because you see this blue line, and that blue line shows you that they're all connected together. Now the second row is all connected together. So all the holes along the second row are connected together. Same thing with the bottom row. All of those holes are connected together. And the second to the bottom row, all of those are connected together. So the top two rows, special cases, the bottom two rows are special cases. Along a column, you're connected. Along a row, you're not connected, and the columns break as it goes over that trench. Okay, does that make sense? I hope it does. So if it doesn't, go back and listen to that again, because you really need to understand how these things work. So we're going to come back now. I've done most of the work for you, right? So what I'm going to need to do is I'm going to need to bring my voltage in, and then that voltage is going to need to connect to what? So you see, what you got to do is you've got to kind of go from this schematic, which is kind of abstract, to a physical circuit here on the breadboard. And so you will be bringing in your voltage, okay? And then that you will want to connect to the long leg of the LED, right? The long leg of the LED. So let's see, I could have something kind of like this, right? Now to connect to that long leg of the LED, I need to connect the voltage, what? In the same column as the long leg of the LED. So can you see that? Same column as the long leg of the LED. And I've just made this connection from pin 13 to the long leg of the LED. Now you've got to figure out where the short leg of the LED goes, and then you're going to have to bring it back home by bringing it to ground. And so what you'll do, this is going to be what your homework assignment is. Okay, now what your homework assignment is to finish hooking this up. Remember, I've got the black wire here. I've got this. Finish hooking this up, and then make this LED blink the SOS. What is SOS? It's 3 fast blinks, dit, 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 and 3 long blinks, da, 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 and then 3 short blinks, dit, dit, dit. So you're going to have to write a program that does dit, 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 da, 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 dit, 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 and you're going to get this to blink. You're going to get this to blink the SOS, the Morse code SOS. See, I didn't finish this for you. You're going to have to think through it. Now, next week, I'll show you the solution. But your homework assignment is to finish fixing the circuit and then write that program. You should be able to do it because we wrote a program to just blink it simply. So now you're going to have to blink it more complicated. And then what you do is you make a video showing your code and showing your circuit working. You post that to YouTube. In your video description, link back to this video. And then in a comment down below, link over to your homework solution so I can run over there and watch that work. So I'm going to see if you can do this with just what I've shown you. And then if you're successful, leave a comment down below. I am Legend. Double chest bump. And if you're not able to do it, leave a comment down below. I fold it up like a cheap Walmart lawn chair. And then next week, what I'll do is I will show you my solution in case you guys are struggling with this. Okay, guys, what have we learned in the first 2 lessons of this class? Well, last week we learned how to program the Arduino, our first program. We learned that if you're going to talk to one of these pins on the Arduino, you have to do a what? A pin mode. Do you want to do it over and over or one time? You want to do it one time. So you put your pin mode where in your void setup. And then you want to what? Blink. You want to blink one time or over and over, over and over. So you put the blinking where? You put the blinking in the void loop. Okay. And then we've learned how to do our pin modes. We've learned how to do delays, and we've learned how to do digital write high and digital write low. And so if you look at what I showed you today in class and you look at what I showed you last week, you guys should be able to come in and you should be able to finish this circuit and you should be able to make your LED blink. Man, I hope I haven't challenged you too much, but you guys do it. Be sure and post your homework. Okay. Now, also, I want to give a shout out to you guys who are helping me out over at Patreon. Really appreciate it. Appreciate you guys standing beside me. Also, you can help me by leaving a thumbs up on this video. If you haven't already, subscribe to the channel. When you subscribe to the channel, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.